Myself, Krishnakumar. So let us begin. So what are the different basic fundamentals which we have to learn? So let us start with physics. How do you understand physics? So physics is a branch of science which deals with the study of nature and natural phenomena. Okay, so whatever you see by your eyes, okay, or the phenomena which may be visible, may not be visible, everything is included in physics. Whatever you see or whatever you may sense, okay, all the phenomena are related to physics, we can say. Our study of that phenomena with some equations, with some fundamentals, that is called physics. Okay, the quantitative science, okay, where the various physical quantities are measured. So like length, okay, volume, density. So such a kind of physical parameters will be there, physical quantities will be there, and that we have to measure in the physics. Okay, so this kind of study is there, and basics of this will be there in your 11th and 12th standard. Okay, now what is a physical quantity? Quantity or physical quantity can be measured, the things which can be measured with the help of some fundamentals, with some laws, okay, and by using that we can explain the natural phenomena or physical phenomena, whatever happening in the universe, that you can explain by using that quantity, okay, and which should be measurable, is called a physical quantity, like a length, mass, time, etc. Okay, so a pen cannot be a physical quantity, but length of pen can be a physical quantity, diameter of the pen can be a physical quantity. A house cannot be a physical quantity, but its length, its height and width and whatever you can measure, and in terms of that we can explain our we can describe the house also. Okay, so whatever it may be, we can express it in terms of some quantities, and that quantities are called physical quantities. Okay, they are having certain units also. Now, so these physical quantities should be measurable. So what is measurement? What is measurement? So measurement is it is basically a comparison with internationally accepted standards. The standards are called units. Okay, by using that unit we have to measure that physical quantity. Okay, so and suppose for example a measured quantity is m, okay, and it is expressed in n terms, okay, and followed by its units. So that can be described as m is equal to n into u. M is some physical quantity, n is its measurement, measured value, and u is its unit. In this format, every physical quantity is mentioned, represented, or we can say measured. Okay. For example, suppose a length of wire is expressed as a 2 meter. We have measured length of that wire using some scale or something, and that is 2 meter. Okay, so that 2 meter or 2 is the expression of that length in the unit of meter. Okay, in the unit of meter. It can be centimeter, it can be any other unit you can use, that you will see different types of units. Okay, so in this way the things are measured. Basically it is a comparison. Okay, if you bring some 1 kg sugar, suppose, if you want to, if you go to the shop, and so what the shopkeeper shopkeeper will do, he will put 1 kg weight in a pan, and 1 kg sugar he will pour on that, and when it will balance, it will say you this is 1 kg, take it. Okay, so in that, so what he is doing, he is comparing that sugar with the standard weight which is available with him, right? So basically, and this is what we are doing for everything, we are comparing with the standards. That is called measurement, right? Now, next part is a unit. We have to measure, and for that we need a unit. So what is a unit? So unit is, it is a standard measure of any physical quantity, okay, and that is called unit. Okay, means it should be internationally accepted. Okay, so another definition or another way of expressing the unit is it is something by which a physical quantity can be expressed. Suppose length means some distance, okay, but how much it is? Meter, centimeter, millimeter, foot, okay, so like this. Okay, so that is called unit. By using that we can express a physical quantity. Okay. Now there are different systems worldwide accepted. And nowadays only SI system is used, but in past many systems are there. Still in some country some systems are used. So what are those different systems of units? So first is CGS system. What is this CGS system? CGS system, it stands for a centimeter gram second system. Okay, C means centimeter, G means gram, and S means second, centimeter gram second. In this system, the length is measured in, or expressed in centimeter, and gram is expressed mass is expressed in gram, and time is expressed in second. Okay, so actually these are important parameters, we can say. Length, mass and time, these are the very important physical competition, or in everywhere either one of these will be there. Length, mass and time will be there. Okay, so that is why the systems are expressed in these three what you can say physical quantities. So that is a centimeter, gram and second. Another system, this CGS system is mostly used by the Americans. Okay, second is MKS system. In MKS system, or it stands for M means meter, K means kilogram, and S means second. Okay, that is why MKS system. So here this length, mass and time are expressed in meter, kilogram and second respectively. Right. Now, another is FPS system. FPS means it stands for foot, pound and second system. Okay, so in this length is measured in foot, weight or mass is measured in pound, and time is in second. Okay, so time is measured in second in all types of system. This FPS system is mostly used by English people, Great Britain people. In that country this FPS system is mostly used. Okay, but recently there was a confusion. A new system is developed because there was what you can say confusion between all this system, because somebody may express a length in centimeter. Okay, and sometimes it may happen that he says one length. Okay, because he assumed that 1 means 1 centimeter, but another person is using MKS system, so he may treat 1 as a 1 kilometer. Okay, or one may treat 1 as a 1 foot. Okay, due to that sometimes mistake may happen, and that is why all the country people worldwide, they have decided we should follow only one system, so that there will not be any confusion inside your country. Okay, but if you want to interact with the other people, other country people, we should use a standard system or unique system, you can say. That is why they have developed another system. That system is SI system. Okay, system international. So this system is worldwide accepted, and this is just like your MKS system. In this length, mass and time are expressed in meter, kilogram and second respectively, and as I told you, it is internationally accepted, and it is used now all over the world in every country. And this SI system use decimal system conversion. Due to that, what will happen, conversion of units is very easily it is done. Okay, if some unit is in centimeter or FPS or maybe in MK system, easily you can convert into SI system, because in SI system decimal system is 10 raised to power minus 2, 10 raised to power 5, like this it is used. Okay, so this is a very important and mostly used worldwide system of the units. Now look, now next important parameter or important part which we have to discuss is fundamental quantities. Okay, so what are the fundamental quantities? So physical quantities which do not depend on any other system, any other quantities for their measurement are called fundamental quantities. Means what? Suppose length do not depend upon anything. Okay, so it is not combination of any other parameters. Length means length, directly we can measure it. Take a scale, put it somewhere what you want to measure and measure it. Okay, like mass. Okay, so there is no combination of anything. Mass means mass. Okay, so there are such a kind of quantities, and those are directly measured, are called fundamental quantities. Now what is fundamental unit then? So units of all these fundamental quantities are called fundamental units. Units of the fundamental quantities are called fundamental units. So there are basically 7 fundamental quantities worldwide accepted, and their SI units and symbols are given below. So first fundamental quantity is length. Its unit is meter and its symbol is m, means symbol of unit. Symbol of unit is m. Another is mass. It is measured in kilogram. SI unit is kilogram and its symbol is kg. Third one is time. Its unit is second and the symbol of the unit second is s. Electric current is also fundamental quantity, and this is measured in electric current is measured in I forgot to write that it is electric current is denoted by I, and its unit is ampere. Okay, and the symbol of that ampere is A. Okay, now temperature. Temperature is also a fundamental quantity. It is measured in Kelvin. SI unit of the temperature is Kelvin, not degree centigrade. Remember, Kelvin, and symbol is K. Amount of substance. Okay, in chemistry you will learn what is this amount of substance basically. In physics also sometimes we have to use, very rarely, and its unit is mole, MOLE, and its symbol is MOL, mole. Okay. 7th fundamental quantity is luminous intensity, and its unit is candela. It is denoted by CD. Okay, symbol of candela is CD. Luminous intensity means this brightness, or what you can say, this light. Okay, that is expressed by this luminous intensity, how much bright it is. Okay, that is expressed in candela. Okay, so these are the fundamental units. There are some supplementary quantities are also there, supplementary quantities and units. So there are basically 2 supplementary quantities. First one is plane angle and solid angle. So this plane angle means your simple angle, 2D angle, and this solid angle is a 3D angle. These supplementary units or the units of the supplementary quantities are called supplementary units. Okay. This plane angle is measured in radian. Notation is RAD, and this solid angle is measured in steradian. Its symbol is SD. This plane angle is a 2D angle, as I told you, and solid angle is a 3D angle. So here you can see this figure. Look, this is a 2D angle. Okay, so this can be described or drawn on a plain paper like this. This angle is d theta, and this is a radius, you can say. Actually, this plane angle, which can be denoted by theta or d theta. If it is small, it is denoted by d theta. So this angle gives you a length of arc. Okay, a length of arc, and relation between this length of arc and this angle and this radius is ds is equal to r into d theta. Okay, so this d theta here in this relation is called plane angle. Okay, means length of arc is subtended, or length of arc forms a angle, then that angle is called a plane angle, 2D angle. Okay, if length of arc is 2 pi r, then this angle will be 360, means it will become a circle. Okay, now here this solid angle forms a surface. For example, let us take this what you can say pouch. Okay, it is a cone like structure. Okay, so this is a surface, suppose, and if you join all these points, to one point here. Okay, so this angle, this 3D angle is called a solid angle. Okay, this 3D angle is called solid angle, and this angle forms a surface here. Or you take one sphere. Okay, one sphere, and take one surface on that sphere. Take one surface on that sphere and join all the points of that sphere to the center. Okay, so it will form a cone like structure like this. Okay, cone like structure like this. So this is called solid angle. This is called solid angle. So here also this is denoted by omega, or a small angle d omega, you can say. This r is the average radius, we can say. There are, so all these points are joined for understanding only 4 points I have joined to the one point, and all these distances approximately equal, let us say r, and this will form, this surface will be equal to r square into that solid angle. Okay, so this d omega in this equation is called a solid angle. Okay, so this is a 3D angle. So this surface here is a solid angle. Okay, so next part is derived quantities and derived units. Now look, the physical quantities which depends on fundamental quantities. Okay, they are not independent. Fundamental quantities are independent, but this quantity, there are many quantities. Okay, other than that 7 and these 2 are derived quantities which depends on the fundamental quantity for their expressions, and their unit of this derived quantity is called derived units. Okay, for example, velocity. Velocity depends upon what? Length and time. Velocity depends upon length and time. Okay, so this v, distance upon time. Rate of change of displacement is called velocity, no? So displacement, let us say distance, means length. Fundamental quantity in that is length. So its unit is meter per second. So meter per second is a combination of meter, which is a fundamental unit, second, which is a fundamental unit, and combination of these two is a derived unit, we can say. So meter per second is a derived unit, and this velocity is a derived quantity, we can say. Clear? And all the physical quantities other than fundamental and supplementary, means other than that 7 fundamental, 2 supplementary, other than these 9 quantities, all other quantities are derived quantities. All other quantities are what? Derived quantities. Okay, so there are number of thousands of quantities, then all take help of these fundamental quantities and they are described. Clear? Sign convention. Okay, so what are the different sign conventions we can use, or we can, whatever the important things which you must remember while describing or while writing the units that we are going to discuss. First of all, the units of physical quantity should be represented by its symbol. Okay, units means, suppose the length. Length can be expressed in terms of its units, and its unit is what? Meter. Suppose SI unit is meter, so it should be represented by m. Now full name of units always starts with smaller letter, even if it is named after a person. Okay, suppose for example here Newton, unit of force is a Newton. Okay, so while writing Newton, normally we write n as a capital because it is the name of the person. Newton is a name of scientist, so name of person, as per law of English we should write n as a capital. But if we are treating Newton as a unit, because that unit is given in the name of that scientist, so that becomes a unit now. And as a unit, if you want to write, you should write with a small letters. That n should be small here, 1 Newton. So this n should be small, not capital. Okay, but if it's short form n, its symbol will be n, no. So n should be capital. Remember, n should be capital. Newton, N-E-W-T-O-N should be in this, n should be small. All letters should be small in the unit. Like Joule. Joule is also name of scientist, means name of person. So J-O-U-L-E, in this J should be small. All letters should be small. Normally we write J as a capital, but you don't write. Okay, but its symbol J should be capital, like this. Okay, remaining is okay. kg, kilogram. It is not name of person, so all are small letters. Okay, and kg is also small. Kg is a small letter. Its k should not be capital because it is not a name of person, you can say. So while writing kilogram, k you can write capital, no problem. But kg, its symbol should be small. But if it is a name of person or name of a scientist, then if you want to write complete unit N-E-W-T-O-N like this, n should be small. Remaining letters as usual small, no problem. Okay. Now symbol for the units do not take plural form. Means it should not be newtons, meters. Okay. 10 meter, not 10 meters. 100 Newton, not 100 newtons. No, only Newton. Not NES, not newtons, nothing. Okay, only in the singular form we have to write, whatever it may be quantity, 10, 20, 100, more than 1, no problem. Okay, it should not be plural. Symbol for the unit do not contain any full stop at the end of recommended letter. Okay, suppose 10 Newton, force you are writing, 10 Newton. So if the sentence completed, then you can put full stop. That full stop will be for the end of the, or to terminate that sentence. But if it is in between, after n, you should not put a full stop. N is not a short form, it's a unit, it's a symbol n. Normally when we type a dot there, okay, when it is a short form we are using, okay, but n is our symbols are not the short form, or n, j are not the short forms, they are the symbols. So do not put full stop after that symbol. The unit of physical quantities in the numerator and denominator should be written as one ratio. For example, unit of acceleration is meter per second square, okay, or we can write like this, meter s to the power minus 2, okay, but you should not write this meter per second, no, meter per second square like this, or meter space s to the power minus 2 you can write, but not like this. Clear? This is very important. Many students write like this. No. Now, in a combination of units, most of the times, if in the case of derived units, it is a combination of fundamental units, more than one are there. At that time, combination of this unit name or unit and its symbol should not, we should avoid it. Like this here, unit is joule per kg per Kelvin is correct, but in place of joule, this, if only j is there, then joule small j, it is accepted, but it is not only one here. In combination with that, kg and k is there, no. So this joule completely written and kg short forms are used or symbols are used. So this combination is not accepted. This combination is not accepted. Either you can write joule per kilogram complete into Kelvin complete, that is accepted. Okay, joule, joule per kilogram into Kelvin, kelvin, like this you have to write, that is acceptable. But one unit is in its name means joule, and for other you are using symbol, this combination is not accepted. You have to write like this. Clear? Another, space or hyphen must be introduced while indicating multiplication of two units, means suppose meter per second. So it can be written as a meter per, here there is a mistake, let us say this is a square, just a minute. So this is a square, no, meter per second square suppose, this is meter per second square, meter per second square. This can be written as what? Like this. This can be written as meter per second square, m space s to the power 2, or you can write m hyphen s to the power square. Okay, you should not use dot there or multiplication sign. This multiplication sign in between m and s is not acceptable, or dot is not acceptable, hyphen is acceptable and space is acceptable, or simply you can write like this, meter per second square. Clear? So now here do this correction, here square should be there, no, here meter square should be there. Okay, now look, this prefix symbol is used before the symbol of the units. Prefix means what? Suppose prefix symbol and symbol of the unit constitute a new symbol, okay, for the units. Means what? Suppose for example 10 raised to power minus 3 second is there, means it is a millisecond, okay. So millisecond means what? Another form is there, another form is there, okay. So this combination of this prefix, this is the prefix of the unit, this prefix and this s is a symbol of the units, this combination forms 1 meter per second. So another unit will be there, or what you can say, new symbol will be there, new symbol will be ms. Now here we should not what you can say, you should not put space or hyphen or dash, nothing should be there in between m and s. M and s is itself is a symbol, millisecond, okay. Now in this sometimes suppose 10 raised to minus 6 second is there, 10 raised to minus 6 second is there, like this. So one can write 1 10 raised to minus 3 means millisecond, and another remaining 10 raised to minus 3 is millisecond. So 1 millisecond or mms, no, it is not acceptable. Okay, what we have to write? 10 raised to minus 6 means what? Microsecond. Okay, so this 1 MMS is not acceptable. Double prefixes are not acceptable. Clear? So these are the all basics we have learned today. Okay, so we have learned definition of physics, then quantity, its definition, then measurement, units, system of units, then fundamental quantities, supplementary quantities, derived quantities, their units, and the sign conventions to be followed while writing the units of all the quantities. Okay, so today we will stop with this basics, and in the next lecture we will start another important topic, that is dimensional analysis, which is included in our this chapter, units and measurement. Okay, so till then, goodbye. So